All right, so basically in order to answer this, we have to know what percentage of data is in between there, and then we can find that probability. So basically, let's remember this. This is the normal, this is the empirical rule. If that's normally distributed, then this is the mean, and then this would be the mean plus 1 standard deviation. And then this would be the mean plus 2 standard deviations. And this would be the mean plus 3 standard deviations. So if I want to know the area between that curve from 1 to 3, I want to know the percentages here. So basically what we're going to do is we're going to add up 34% plus 13.5% plus 2.35%. And if you add those, well, it adds up to be, we go 49.85%. So that probability is a 49.85% chance of that actually happening. We like to write probability as a decimal though, so we can call that 0.4985. This is written as a percent, but generally we like probability written as a decimal. So the first question asks, what's the probability of choosing data between there? And that is 0.4985. Or if you said 49.85%, no one would be upset about that. Go to the next one, but I want this. Next says, what's the probability of x being greater than the mean plus 2 standard deviations? So that's probability of x being greater than the mean plus 2 standard deviations. Let's go back to that curve. So this is the mean plus 2 standard deviations here, and that means outside this range. So that answer would be 2.35% plus 0.15%. So that would give you 2.5%. And as a decimal, 2.5% is 0.025. So probability is 0.025 or 2.5%. All right, so that's what that is. Example 2 says, on a box of cereal, the weight is listed as 12 ounces. Among all the boxes of cereal of this type, however, the actual weights approximate a normal distribution, which with a mean of 12 ounces and a standard deviation of 0.1 ounces. So before we can begin, we got to draw that picture. And that picture would look like this. So the mean is supposed to be 12 ounces. So we put 12 as the middle. It said normally the standard deviation is 0.1 ounce. So it's going to be 12.1. And then 2 standard deviation is 12.2. Then 3 standard deviation is 12.3. Now on the back end, I'm going to take away 0.1. So it's going to be 11.9, 11.8, and 11.7. This is my mean. So this is the normal curve. So you have to do this every time before you start the problem. It says, what is the probability that the contents of a randomly selected box of cereal of this type is within 0.1 ounces of 12 ounces? So it's basically within 1 standard deviation. That's what the standard deviation is. So this is 1 ounce on the left, and this is 1 ounce on the right. If you remember, it's 34% here and 34% here. So it gives you a 68% chance of selecting the cereal that is within 0.1 ounce, 12 ounces. So you can call it 68%, or as a decimal is 0.68. Again, this is 6 here, so it says 68. And truth be told, a lot of people write it as decimals anyway, as a percent too. So if you see it written as a percent, don't worry about it. Probability is pretty interchangeable. All right, so the next question says, how many boxes of cereal out of 5,000 can a manufacturer expect to be written in this range? So basically, if there's a 68% chance of the boxes being in that range, I would basically take 5,000 and then multiply by 0.68. Because that's a 68% chance of getting a box in that range. So 5,000 times 0.68 should be 3,400. So it should be 3,400 out of every 5,000 you're in that range should be in this range of 1 standard deviation away. All right, I'll give you one last example. That's actually over my 15-minute mark. I like to keep them under 15 minutes, but if you want a practice example, here's a new one. And yeah, we can talk about it in class, but that's my last example. That's all I have. Good luck.